everyone. Today we'll be talking about magnetic fluid, also known as the ferrofluid, which is a very cool liquid that has some really neat magnetic properties that we're going to be getting into. So, what is ferrofluid? So, ferrofluid is a colloid liquid, which is a liquid that is a mixture of microscopic particles that are dispersed through a soluble or insoluble substance. The colloid has two phases, the dispersed phase and the continuous phase. The particles are usually suspended until it separates in the continuous phase. For a mixture to fully be considered a colloid, the mixture must have a settling particles or take a very long time to settle. The ferrofluid liquid has ferromagnetic properties that can be ripped out of the mixture, forming a separate clump of magnetic dust when exposed to a magnetic field. The magnetic attraction is weak, but still shows on the surface of the fluid when it comes in contact with an actual magnet, which is what we did with today's experiment. Real-world applications of ferrofluid. Ferrofluid can be used as liquid seals around disk hard drives and stuff like that in electronics. It can also be used in mechanical engineering because of its friction-reducing capabilities. It is used as a semi-active damper in mechanical and aerospace application. It's also used in loudspeakers. They've been used in loudspeakers to remove heat from the voice coil and to passively damp the movement of the comb. In the medical world, it also has a lot of good applications, one of which is when it's used as a contrast agent in magnetic resonance imaging, or the MRI machine, for the radiologist to see what's going on with your body. So the interesting thing that makes the ferrofluid magnetic is the iron oxides that are within it. So characteristics of iron oxides, there's 16 different types of them. They're composed both of iron and oxygen, like 16 isotopes. Usually it's useful as a catalyst in industries and hemoglobin blood circulation. So you can find iron oxides in basins of sedimentation and magnetic deposits that occur deeply in North America. Demands for iron oxide are second to just being as high as gas and oil. So it's a very interesting compound that has the ferromagnetic property, which is in the ferrofluid that we use today. So the magnetic properties is due to the unpaired electrons in the 3D orbital shell for it. So because it has those unpaired electrons, it's got that extra energy there. The materials have a relative magnetic permeability greater than 1, and they are attracted to magnetic fields, i.e. the rare earth metal that we're going to use today. When an external magnetic field is applied to the ferromagnetic material, the magnetization increases with the strength of the magnetic field until it approaches saturation, meaning they just collide with each other. So, the experiment. So the materials needed were the ink toner, vegetable oil, and the rare earth metal. The rare earth metal is the neodymium earth magnets right here. I got this at Home Depot. It was about $5. It's a very strong magnet. That's why they chose it for the experiment. They use it in a lot of other applications. It can be very, very powerful depending on the concentration of the rare earth metal. So that's what they use here. Unfortunately, I couldn't find the ink toner powder for the experiment, so I wasn't able to fully do it out. So I was upset with that because I was like, okay, I got the magnets. It was hard to find that, but then the ink toner powder for the laser one, which has the iron oxides in it, I checked Staples. They didn't have that one there. But the neodymium magnet reacts with the ferrofluid to cause it to spike, basically because of the magnetic properties and the iron oxide particles within the ink. I was able to find a video that had the use of it there, and I'll just scroll through this so you guys can see it here. So basically with the ferrofluid that they made, this is the ink toner, laser printer toner. That's the one that I needed. I couldn't find that one. The vegetable oil. Mix that up together really good. Made the ferrofluid. And then that's the neodymium earth magnet. And it shows that the iron oxides are attracted to the magnet. And if you want to make it in a bottle, they're showing it here where you can get a funnel and put some ethyl alcohol, which doesn't mix with the ferrofluid very well, so it just makes it look cooler, and you can play around with it and have your own ferrofluid at your house. If you looked at the price for ferrofluid, it's actually very, very expensive. So definitely not something that you want to just buy out on the market, because it is extremely expensive. But if you can make it and find the ink toner, laser jet ink toner with the iron oxides, then that'll be perfect for you to use at home. I just wasn't able to find it in the amount of time given. So in conclusion, the ferrofluid is the nanoscale liquid that has iron particles that are suspended in the colloid fluid mixture. When the mixture comes in contact with an external magnetic field or the neodymium earth metal, the rare earth metal will then spike and have a magnetic effect. Ferrofluid has many real-world applications, like serving as contrast for radiologists in the medical industry, as well as energy harvesting from vibration energy in the environment. It's actually very impressive because they proposed it to be a form to use in nanosurgery to separate one tissue from another, and they use the example of a tumor from the tissue which is grown in. So if it can separate a cancerous tumor from the tissue because of its magnetic properties and application within the human body and hemoglobin, that would be very, very impressive if they can get that to work. So ferrofluid is definitely a very, very valuable fluid. That's why it's so expensive, and it has a lot of applications. And then these were the references where I got my information. And thank you so much for watching this video.